Hello children and welcome to this session today. Children, up till now we have learnt about many substances. Right from our junior classes, we are learning about what different things are made up of. And today in this class we are going to learn more about substances. But before we begin the chapter, let us take a simple example. Suppose I ask you to put your sketch pens, your crayons, your pencil, eraser and your pens into one big pouch. And then I ask you to take out maybe pink crayon from it. How difficult is it going to be? Yes, it is going to be difficult. On the contrary, if I ask you to keep all these things separated and then I ask you for a pink crayon, you will quickly be able to locate the pink crayon from the crayon pouch. Isn't it? This is what brings us to the topic of the day. Chapter number 5, Separation of Substances. In this chapter, we are going to learn about mixtures and pure substances, the need of separating substances, the methods of separation, solubility, and importance of water as a solvent. So just now in the example that we discussed, when we put everything into one pouch, what does that become? It becomes a mixture. Another example of mixture is the atmosphere. We know that there is a layer of atmosphere around the earth which includes gases like nitrogen, oxygen, argon, carbon dioxide, and it also includes water vapor. Now, out of these, if I was to talk about only an oxygen cylinder, a cylinder which gives us only oxygen, what will that become? That will become a pure substance. So, we come to the conclusion that in our environment, there are mixtures and there are pure substances. Now, next, we are going to understand the general properties of a mixture. In a mixture, components retain their original properties as there is no chemical reaction. For example, in thermite mixture, iron and aluminum powder are mixed together. They do not react. So, the first thing that is in a mixture, all the different elements that are present will retain their properties. In the atmosphere, nitrogen, oxygen, argon, carbon dioxide, all these maintain their properties, right? The second thing is the constituents of the mixture can be separated very easily. Now, to be able to distinguish and separate the components of a mixture, we need to understand what are the types of mixtures. Children, there are two types of mixtures. There are heterogeneous mixtures and there are homogeneous mixtures. Now, in a heterogeneous mixture, for example, if I were to create a mixture of say two shapes, a triangle and a circle. So, in a homogeneous mixture, what will happen? The triangle and the circle will be distributed equally in the whole mixture. Whereas, in a heterogeneous mixture, their composition is also going to be different and their distribution throughout the area is also going to be different. So, there may be more of circles and less of triangles. Also, in one area, the amount of circles may be more and triangles may be less. So, this is the difference between homogeneous and heterogeneous mixture. Now, let us come back to the properties of these mixtures. Homogeneous mixtures are even throughout the volume with respect to composition and the components are equally distributed. Also, they cannot be separated by simple methods like straining or sieving. Coming to the properties of heterogeneous mixtures, they are distributed in indefinite ratio that we have just understood. Second thing, different parts of heterogeneous mixtures are different. So somewhere the circles are more, somewhere the triangles are more. And the third, they can be separated easily by hand picking, screening, etc. Now, why do you think we need to separate materials? For example, I want to cook dal. I will take dal, spread it in an open plate, and I am going to pick out any impurities from it. There may be stones, there may be pieces of husk, etc. So, why do I need to separate? Because I want the pure dal, right? So, there are certain other examples that are given in your book. The first example is that air around us is a mixture of gases, and it also contains dust, pollen, allergens like for pollutant gases like sulfur dioxide and nitrogen dioxide. Now, these are undesirable in nature. So, that is why we need pure air to breathe in. Another example that has been given is to obtain substances of choice in pure state. So, when we are making gold ornaments, what do we want? We want pure gold, right? If there are other elements clinging to gold, then it is not going to remain pure. That is the reason it is important to separate substances. The next example is obtaining ores like bauxite, hematite, etc. They contain a lot of impurities. Now, in order to use these ores, what do we need to do? We need to filter out the impurities. Children, there are different methods of separation for different items. Let us learn about them one by one. Separating insoluble solids from liquids can be done by using different methods. Sedimentation. Insoluble solids like mud present in water settle at the bottom of the container. They are kept in after some time. The particles that settle down are called sediment. Sedimentation is the process in which the heavier particles of an insoluble solid in a liquid settle down. Decantation follows sedimentation. It involves pouring out the liquid on the top carefully into another container without disturbing the sediment. Decantation is the process of passing out the liquid without disturbing the sediment. Filtration. You must have seen your mother pouring tea through a strainer to separate the tea leaves. This process is known as filtration. Therefore, filtration is the process of separating the insoluble impurities present in a liquid by using a filter like a thick cloth or a sieve. Soluble solids can be separated from liquids by evaporation. Put 1 teaspoon of salt in a glass of water and stir it. The salt dissolves in water. Salt can be obtained from water by boiling the salt solution. Boil the solution till the water evaporates completely. The white residue that is left in the container is salt. If you hold a seal plate above the evaporating water, the steam that comes in contact with the plate condenses to form liquid water. Evaporation is the process of changing water to water vapor on heating. Condensation is the process of changing water vapor to water on cooling. So what have we understood from this video? We have understood the processes of filtration, sedimentation, and we have also understood how a liquid can be separated from a mixture of liquid. Now let's come to separation of solid from solid. In order to separate a solid from solid, what are the criteria that the mixture should meet? Number one, color of components of the mixture should be different. The different components should differ in shape and size, in weight, in magnetic properties, and the solubility of different components in water is different. Let us first take the example of sieving. Now, we very well understand that sieving is something very common that we do at home also. If we are taking the wheat flour from a local granary, they have husk mixed in the wheat. Before kneading it into a dough, what does your mother do? Your mother sieves out the bigger particles of the wheat flour. So what happens? You get pure simple wheat flour, which is very easy to create into a dough. The second is hand picking. As we discussed in the example of preparing dal, where we pick out the stones and the husk particles. What is that? That is hand picking. The third way in which particles can be separated is known as magnetic separation. So, in magnetic separation, it is done in industries. How is it done? As we can see in the picture, the finely ground ore is run through a magnetic roller. All the magnetic particles stick to the roller and they fall in a separate place, and the non-magnetic substances fall in a separate place. Now, children, in agriculture, there are two very common ways of separating particles. When the grains are ready, what do the farmers do? The farmers do threshing. What is threshing? In threshing, the crops are removed from the field. After that, what is done? The grains are removed from the stalk. This is threshing. After threshing, the stalk and the grain, some particles of the stalk remain with the grain. So, what has to be done? They have to be separated. And how it is done? It is done by winnowing. What is winnowing? The grains mixed with stalk are allowed to fall from a great height. The air carries the lighter stalk away and the grains are piled up in a separate pile. Next, let us understand about a solution. So, let's take the example of water in a container. Let me add to it, say, 2 teaspoons of sugar. Now, the substance that is taken in the container is known as the solvent, which will dissolve the other substance into it. And the substance that is going to dissolve is known as the solute. And together, solute plus solvent make up the solution. There can be two types of solution. First is a dilute solution. Second is a saturated solution. Now, let's continue understanding with this example only. So, if I add 2 teaspoons of sugar in a glass of water, it is going to mix very well. Now, let me change this amount to, say, 10 teaspoons of sugar. If I continue stirring it, then maybe at some point in time, the sugar will dissolve. But if I change this quantity of sugar to, say, 20 teaspoons of sugar, what will happen? Some of the sugar will remain deposited at the base of the container or the glass. Now, this solution in which there is some remaining particle left of the solute, it is known as a concentrated solution. What do you mean by concentrated? Concentrated means where no more solute can be added. And a dilute solution was a solution with 2 teaspoons of sugar, where you could continue adding more sugar. So, these are the two types of solutions, dilute and concentrated. Now, as we know that we made this solution in water, it is important for us to understand that water is known as a universal solvent. That means many things around us, solids, liquids and gases, dissolve easily into water. That is why it is known as universal solvent. And that is why water is very important as a solvent. So, we know that plants absorb water from the roots in order to carry out photosynthesis. We also know that we need to drink water to stay hydrated, so that all the movement of different nutrients in our body, the waste products in the body, is done effectively. Similar case is for animals, where they also need a lot of water to drink for the movement in the body. And we also know that aquatic plants absorb the oxygen that is dissolved in water. Aerated drinks have dissolved carbon dioxide in them that help to create a lot of fizz in the drink. So, children, in this chapter, we have learned so much about substances. We have learned about pure and impure substances. why there is a need to separate substances, what are the ways in which these substances can be separated. So hope you thoroughly enjoyed the chapter like we did explaining it to you. Thank you.